This is a short video on sequences, on identifying linear sequences. The first thing to point out is that linear sequences can also be called arithmetic sequences, and these are the exact same thing. So a linear sequence is an arithmetic sequence. So let's look at an example of a sequence, and a sequence is just a list of numbers. And it's a list of numbers that follows a rule. The first thing we do to identify a linear sequence is we identify the term-to-term difference. This is just what it takes to get from one term in the sequence to the next. So for example, to get from 1 to 4, I add 3. If I look through the sequence and identify all the term-to-term differences, I can see that in each case, I'd need to add 3 to get from one term to the next. If I find myself in a situation like this example, where all the term-to-term differences are the same, that means I have a linear sequence. So I can say there's a constant term-to-term difference, and this implies that I do in fact have a linear sequence. Here's a second sequence, 1, 4, 9, 16, and so on. I want to identify if this is a linear sequence. I look for the term-to-term difference. In this case, I have plus 3, plus 5, and plus 7. You can see in this case that these term-to-term differences are not all the same, so I don't have a linear sequence. There is, however, some pattern going on. And you can see here, if I was to go an extra layer in, that I can find the difference between the differences. So each time 2 is getting added to the difference to generate the next term. You can probably predict what the next term in the sequence would be. I'd need to add 9 and I'd get 25. But even though I can do this, it's still not a linear sequence because the term-to-term differences, this pink line, weren't the same. Now, you can see that I can keep going down through different differences, so it's important to have different names for those. I'm going to call this first line in pink, that term-to-term difference, my first difference. And the next layer I'm going to call my second difference. So now instead of saying term-to-term difference to refer to this line in pink, I'll just call it first difference instead. So I don't have a constant first difference, so I don't have a linear sequence. So I do have a sequence, I do have a pattern, but because I have no constant first difference, then I don't have a linear sequence. Here's another sequence. This time it's 10, 8, 6, 4, 2, ... to indicate that I could continue on. I want to figure out if it's a linear sequence or not, so I have to identify the differences. So like I said previously, I'm now going to call the term-to-term difference the first difference. So how do I get from each term to the next? Well, to get from 10 to 8, I have to take 2. What do I have to do for the remaining terms? Well, to get from 8 to 6, take 2, from 6 to 4, take 2, from 4 to 2, take 2. And I'll write those all in. I don't need to go any further. I can see that I've got a common first difference. So this tells me that I'm going to have a linear sequence. Because I have a constant first difference, I do have a linear sequence.